In this lesson we're going to look at mathematical expressions. If we look at an equation like 2x plus 1 equals 5x plus 7, each side of this equation is an example of an expression. So 2x plus 1 is a linear expression in x. 5x plus 7 is also a linear expression in x. A linear expression in x has only got constant terms, like plus 7, and terms involving x, like 5x. A linear expression will not have any x squared terms, or x cubed terms, or any higher powers of x. Let's look now at some quadratic expressions. X squared plus x plus 1 is a quadratic expression because it has got an x squared term. So this is a quadratic expression in x. Another example, 2y squared minus y. This is also a quadratic expression, so it's got a y squared term. It's a quadratic expression in y. So if we look again at our quadratic expression in x, x squared plus x plus 1. This can be written as x squared plus x to the power of 1 plus 1. X just means x to the power of 1. So we can see that this quadratic expression in x has a constant term, it has an x to the power of 1 term, and it's got an x squared term. It doesn't have any x cubed, x to the power of 4, or any higher powers of x. A quadratic expression can have different coefficients. For example, 2x squared minus 3x plus 4. A quadratic expression doesn't have to have a constant term, so we could have something like 2x squared minus 3x. A quadratic expression doesn't have to have an x term, so we could have 2x squared plus 4. Each of these three expressions are quadratic. Just like numbers, we can add, subtract, multiply, and divide expressions. For example, if we were asked to simplify x plus 1 plus 2x minus 2, we can remove the brackets, so it becomes x plus 1 plus 2x minus 2. Now we group together the terms that are alike. So we're going to group together the x terms, so x plus 2x, and we group together the constant terms, plus 1 minus 2, because we can only add and subtract like terms. That's the same as 1x plus 2x plus 1 minus 2. So 1x plus 2x is 3x, plus 1 minus 2 is minus 1. So our original expression has been simplified to become 3x minus 1. We can also multiply an expression by a constant. For example, 3 times x minus 2, which is equal to 3 by x is 3x, 3 by minus 2 is minus 6. So we can see that to multiply an expression by a constant, we multiply every term in the expression by the constant. So 3 times x is 3x, 3 times minus 2 is minus 6. We can also add quadratic expressions. For example, x squared plus 2x minus 2 plus 3x squared minus x plus 1. Well, that's the same as x squared plus 2x minus 2 plus 3x squared minus x plus 1. Remember that minus x is the same as minus 1x. So now we can group together the like terms. So firstly we'll start with the x squared terms, so x squared plus 3x squared. We can cross these off as we go along. Plus 2x minus 1x minus 2 plus 1, which is equal to x squared plus 3x squared. Well, that's the same as 1x squared, so that's 1x squared plus 3x squared is 4x squared. Plus 2x minus 1x, well, plus 2 minus 1, that's plus 1x. Minus 2 plus 1, that's minus 1. Remember that plus 1x is the same as plus x, so we're just going to tidy that up. 4x squared plus x minus 1. So when we add our two original quadratic expressions, we end up with 4x squared plus x minus 1. The most important idea in this is that we can only add or subtract like terms. So we can only add x squared terms with each other, x terms with each other, and constant terms with each other. So we can't simplify our answer here any further, because we can't combine x squareds with x's and constants. So this is the answer in its simplest form. Now we're going to look at multiplication of linear expressions. For example, x plus 1 by x plus 2. So this expression multiplied by this expression. To do this, we expand the brackets. So it becomes x times x plus 2 plus 1 times x plus 2, which is equal to x by x is x squared, x by plus 2 is plus 2x, plus 1 by x is plus 1x, plus 1 by plus 2 is plus 2. Now we check, can we simplify this any further? Well, we have some like terms here. We have plus 2x and plus 1x. We have a quadratic term and we have a constant term. So this becomes x squared plus 2x and plus 1x is plus 3x plus 2. So we don't have any more like terms here, so we can't simplify this any further. So this is our final answer, x squared plus 3x plus 2. Another example, 2x minus 2 times 3x plus 1. Again, we're going to expand the brackets. So this becomes 2x times 3x plus 1 minus 2 on 3x plus 1. So we've split the first expression into two. and each of those terms is multiplied by the second expression. So this becomes 2x by 3x, well 2 by 3 is 6, x by x is x squared. 2 by plus 1 is plus 2, x. Minus 2 by 3x, well minus by plus is minus. 2 by 3 is 6, and x, so minus 6x. Minus 2 by plus 1, minus by plus is minus. 2 by 1 is 2. Again, we've got a quadratic term. We've got a linear term, an x term, and another x term, and a constant term. So to simplify this further, we can group any like terms together. So 6x squared stays as it is. Plus 2x minus 6x, well, plus 2 minus 6 is minus 4, x, and then minus 2. And again, we can't simplify this any further. We've got a x squared term, the quadratic term, we've got an x term, the linear term, and we've got a constant term. It's also possible to divide expressions. This is more complicated. We'll look at this in a separate lesson.